much. So it's my great pleasure here to present our work on building a modular storage layer, especially solve some particular issues on top of Ethereum, the latest update, that is EIP-4844. So first of all, a quick introduction of myself. I have been working in this space since 2018. I was a software engineer at Facebook, Google, working on distributed file systems and high-performance systems. And very active in Ethereum ecosystem. So I have published tons of articles, ideas in terms of in the Ethereum research and magician, and also author a couple of EIPs. And so my primary interest is in Ethereum data availability technologies and layer 2. And so I also received multiple supports from Ethereum Foundation, including the Vitalik's personal grant on cross-layer 2 bridge, and data availability sampling research, and lastly, EthStorage itself. So first of all, why we need Ethereum storage solutions, as we already have a couple of like Filecoin, RV, that are running pretty well these days. And one thing is motivated by the future Ethereum upgrade, where the data availability technology will bring a large amount of data on chain. So one key upgrade is EIP-4844 that is part of the Cancun, which is the first upgrade to support data availability. And so what is data availability? Is a way we are able to scale the Ethereum data publication in using a lot of advanced cryptographic primitives. So here is the roadmap that I captured from Vitalik's tree at the end of last year, where there's a plan for the surge, which is going to support 100,000 transactions per second on top of Ethereum, and where the core technology here is data availability, including EIP-4844, and full DA that is planned in the next couple of years. So what is EIP-4844? It is introduced a new type of transaction of Ethereum, which the transaction can include new object called binary large objects, which has 128 kilobyte size, and it is not be able to access by the EVM itself, but its hash, the commitment, is available on chain. So that with some advanced cryptography, for example, data availability sampling, the consensus can prove that the data corresponding to this commitment is available on chain in their data availability network, rather than access each byte of the data that is available in core data. So in this way, Ethereum is able to scale dramatically in the future through DA, which can create about 50 terabytes of data per year on top of Ethereum network. That is more than 10 times more data that can be generated by current Ethereum network. But the one feature that we found in EIP-4844 spec that was dropped about 2 years ago is that because there's a large amount of data that now can be published on chain, so where is to store this data, especially in the blockchain from our, for example, Bitcoin, Ethereum is expected to store all the data from Genesis. But this creates significant storage burden for all the validators. Imagine 50 terabytes per year for each validator, which means that we have to run a validator with maybe tens or hundreds of terabytes, which is definitely exceeding a lot of capacity of those validator nodes. In order to solve this problem, the Ethereum's solution in the protocol is we're going to discard or prune those data once it's published on chain after 18 days. And this is the first time the Ethereum protocol to voluntarily discard those data once it has been published in a couple of days. So this is the specification that is merged in the Ethereum specification repo. And actually, this data expiration issue applies to all the data availability networks, including Celestia, which maintains data for a couple months, and also EIP-4844 which they would like to prune the data after 14 days. And so this pruning actually creates a new issue or a new fundamental issue on future blockchain, especially for layer 2s, is that if they would like to derive the latest states or security from Ethereum, only of Ethereum, then it has to rely some additional assumption or additional trust, because unlike current these days, those data will be discarded in 18 days. And such plan is already scheduled in next month on March 13. So when we observed such problem about 2 years ago, one idea come up with my mind is that it's possible to extend those data availability so that we are able to incentivize a large amount of storage node that natively running on top of Ethereum network as a superset and store those data with much longer time, potentially forever. With this feature, we are able to offer a lot of unique things to Ethereum. First, it can offer much better layer 2 security for all the ZK rollups, including OpenStack, Polygon, and others. So we have already integrated our system into OpenStack. And second is that with much longer storage solutions, we are able to offer much cheaper storage solutions with large amount of on-chain data, including NFT images, autonomous worlds, and AI model itself. With these technologies, we are able to upload the AI model, which can be a couple gigabytes, and verify its result with the promotes as input until the corresponding output is correct, and which enable a lot of applications that was not possible before. So that's the basic motivation of EthStorage, is a modular long-term data availability layer building on top of Ethereum current called short-term data availability layer, which is built on top of EIP-4844, etc. And first of all, we are a modular ones, so that it can be easily plugging into the current Ethereum virtual machine and the networks, so that we do not require any protocol upgrade except the DA itself. And second, with some enhancement of the token metrics, we are able to achieve a very high and permanent availability of those data that was originally published on top of Ethereum and discarded in 18 days. And lastly, we are able to scale the capacity or storage capacity of Ethereum from a few terabytes now can easily reach to petabytes of data, which means that we are able to upload a large amount of data that was not possible before. How we are able to achieve those features? There are two major innovations that we invented during the development of EthStorage. The first thing is to build an on-chain streaming storage fee distribution. Why? Because there's a huge misalignment of the storage incentivized system on existing Ethereum network. All the storage fee, for example, for the asset store, all those store fee is distributed to the proposer in one time. While all other nodes, validators through nodes, there's no any incentive or penalty to store the data. So there's a huge storage misalignment between the cost and the incentive. We are the first one fix the problem on top of Ethereum, buy, receive upfront storage payment from the user, and then distribute those fees to those storage providers over time, as long as they can prove that they really store this data over the time using our snark-based storage proof algorithms. And these algorithms actually is our next innovations, which is to be able to verify those we call data availability sampling over time with a very, very efficient verifier. And for this research is exactly the one that received the support from Ethereum Foundation. So here is an overview of EthStorage network. It has two major components. One is EthStorage storage contract, which allows any applications to call a put method and say, hey, I want to store this data and this blob in their layer 2 network. And also, it will pay a very small amount of storage fee in terms of Ether so that it will be distributed to the storage providers over time. The second thing is a storage layer 2 network, which is a permissionless network with a bunch of nodes that store the corresponding blob data. Once it receives the data and uploads and download the data from the Ethereum layer 1, it will perform the data availability sampling over time so that they're able to prove the local storage that they store over time, even though the data will be pruned after 18 days. When there's a proof that is successfully created, a storage provider will submit corresponding proof to the on-chain Ethereum smart contract that is deployed by us. And once such verification is successful, then the corresponding storage fee will be distributed to the corresponding storage provider to reward the time and number of the data that is stored by this node. Here is the roadmap of EthStorage. So in the last year, we have a lot of major achievement. One is that we are the first place at the Ethereum Cancun Super Demo, and we raised $7 million at 100 mil. And for this year, we have a lot of planned launched. The first one is we have fully integrated with EIP-4844, and we are going to launch our public testnet shortly. So we have an application of our public testnet at our booth. So feel free to come and fill in your information, and we will invite you guys to participate in our testnet and experiment all these innovations. And so this is the integration part with EIP-4844. We have worked closely with Ethereum Foundation core developers and potentially crash one or two their internal DevNet during the stress test phase. And we have to be able to run the full network when the Ethereum launch is internal DevNet, that is 12. Right now it's public testnet, that is Polia and Holosky. And also we have some third-party community members that are able to come up with a node and prove their local storage by themselves. And EthStorage can be more than a long-term data availability layer of Ethereum. Thanks to smart contract and programmability, EthStorage can do more than just a static file storage system. It's essentially a database with key value interfaces. This enables a lot of dynamic website applications rather than static ones that we can find these days, like Filecoin and Arly. Another interesting differences of EthStorage is that it's fully integrated with Ethereum development stack. As a developer, I only need to have Ether, know how to use Ether wallet and smart contract. And then I can easily store all the data I would like to store and organize by smart contract on Ethereum. So this will be significantly reduce the learning curve of all the developers and users to use EthStorage. We also propose a Web3 access protocol, which is a decentralized HTTP protocol to access those data that is on-chain and be hosted by the smart contract. So the smart contract can define the corresponding logic to display those dynamic data that is uploaded by the users rather than a static ones. And with this, we are able to, especially together with Ethereum scalability roadmap on computation that's current layer 2s, we are able to deploy a lot of applications. For example, decentralized social network, even YouTube, or decentralized gaming. Everything now is able to on-chain, including the front end. So there are a couple of interesting applications that can be enabled by EthStorage and the new access protocol. Here I just give a highlight of fully on-chain AI. So with EthStorage, now we are able to upload a large amount of AI model, for example, potentially 3 or 4 gigabytes of data that is on-chain. We can further be able to verify the inference on-chain given the AI model that we have published in EthStorage, so that we can tell, given a promote and the corresponding outputs, we can tell that this is the correct answer by the AI model, which is impossible before. And also this is powered by OPML, Optimistic Machine Learning, developed by Aura. And this is have some new applications with AI, and this is 2 of some I'm pretty glad to play with them. One is using large language model as the game engine, so that now we are able to use large language model and compose all those elements so that it can come up with more complicated things. And all this composition, the sequence of composition, are available and verified by chain. There are some more advanced things. Now we are able to deploy a text-based DND on-chain, so that we are able to build a fully on-chain autonomous world on top of Ethereum network. So this is pretty much all I have. So many thanks for attending my today's talk. So if you have any interest both in running a node of the network or would like to deploy an application on top of EthStorage or Web3 access protocol, feel free to reach me at QC_QIZHOU. I'm looking forward to see the new Web3 world there. Thank you very much. And yeah, I can also answer a couple questions. Any questions?
Hi, thank you for your presentation. Can you talk a little bit more about the pricing, like the cost of running like a YouTube video or a streaming using the service?
That's a great question. So the question is about the price to, for example, store a video or some like large amount of data, right? So the price actually is not limited by EthStorage itself. It's most limited by Ethereum gas, because the transaction itself need to carry the base gas price, base gas that is 21,000, and a couple of gas to call a contract to basically index the data that I would like to store on chain. So for that part, I think in general, you can imagine we just take 2 as a store to store all this data that is on chain, which takes about $1, $2 according to current gas price. And there's a further improvement of this storage price is to be able to deploy EthStorage on layer 2. So that EthStorage is layer 3 as a storage layer. And in that cases, because the gas price is significantly reduced, the price of storage will be reduced to about 100. That's our current estimation, especially according to the, for example, OpenStack or Arbitron's gas price metering. And so this is something that now we can achieve. And so compared to layer 1 gas prices, the deploying on layer 1 that will about 1 to the 1,000, and deploy on layer 2 that will 1 to the 100,000 versus Ethereum storage, native storage. So that is the maybe single sentence description of the price. Any other questions? One more question.
Hi. So for people who want to retrieve the data, do they have to pay the gas fee for that as well?
So how they retrieve data?
For retrieving the data, do they have to pay the gas fee?
Do they need to pay the gas fee to retrieve the data? Okay, that's another great question. So you can imagine EthStorage is a superset of Ethereum, which means that all the retrieval market of EthStorage can derive existing retrieval market of Ethereum. In general, in Ethereum, there are a couple of retrieval markets. One way is that I run a node by myself so that I can retrieve everything I need. Or I can use Ethereum Alchemy, which will provide some tiers of the retrieval ability in terms of how many requests I would like to make, all these things. Similar things can be applied to EthStorage, even though it's a bit centralized way. There's another interesting thing that we are working is to enable fully decentralized access protocol that work together with Ethereum Portal Network Portal Network. So Ethereum Portal Network is Ethereum sub-project by the Ethereum Foundation sub-projects that is able to enable decentralized JSON RPC by building a DHT network similar to IPFS, but only the data that is verified on-chain. So not any garbage data on IPFS. It has to be verified on-chain. So with that, we are able to also offer this kind of a decentralized access network together with the blobs that is introduced by EIP-4844 and accessed by the application. So there are a couple of ways, but thanks to Ethereum itself, the network itself, we can just borrow the best practice of all these retrieval markets instead of inventing something new and need to be that better tested over time.
All right, thank you so much,
Yeah,
Chi. That was a great talk. Can we give it up for Chi from EthStorage? Thank you very much.